So here we have a really important equation for us. You need to get reasonably good at working with this, because in some questions you'll have different bits of information given to you, and it may not be in a way that's very nice. So you need to be able to work with this equation so that you, no matter what information is given to you, you can work out the bits that are missing. Okay, so here is our z-score. That's what we go to our table with. X here, you'll see this value x. That value x is the value that you're going to be given, which might be a measurement in centimeters or a weight or a number of something. Okay, so it's going to be our real life value. Some measurement that we've got of some kind. I've already explained that this is the mu, so this is the mean. So anytime you see someone say the average, or the question says average, it's talking about the mean. And this is sigma down here, and that's the standard deviations. And you'll be told how many standard deviations most of the time. If not, maybe you'll be working out what the standard deviation is, based on being given everything other bit of information. But I wouldn't get too stressed about that. Okay, so here we go down, and here's a standard sort of question for us. So a group of friends compares what they received while trick-or-treating. They find that the average number of pieces of candy received is 43. Okay, so each of them have got 43 pieces of candy. It's pretty successful trick-or-treating, especially around my neighbourhoods. You'd be lucky for 5. Okay, and there's a standard deviation of 2. God knows why these people worked out their standard deviation. It's not what normal people do, but it's been done in this case, and we're going to use that information to plonk it into this formula that we've got up there. Okay, so what is the z-score corresponding to 20 pieces of candy? Okay, so the z-score, the 20 pieces of candy here, so we need to find out the z-score for that. That's our x value. So you can see I've written it over here, 20. We were told that the mean, excuse me for mixing up my averages, the mean was 43, and we were told that the standard deviation was 2. So here's my x value, bang, there. This is my mu value, there, and this is my standard deviation. And that's all just been written over here. So hopefully you'll agree with me that 20 minus 43 gives me negative 23. And the standard deviation is 2, so I've just divided that by 2, and that gives me negative 11.5. Too easy. Okay, so that gives me my z value. So I'm saying, well, this is basically 11.5 standard deviations away from the negative 11.5 standard deviation. So we're now going to be to the left of our little graph, our little normal distribution. We know we're going to be working on this side here because it's a negative number. So I draw my little line over here. So this is my little z-score here. And I will put this down. And I'm just going to call it 11.5. You call it negative 11.5. And there we go. So there we are. And that's working out a z-score. How good is that? Okay. I'm going to leave you there because I think we have covered how to use formula for finding our z-score. X is the value, mu is the average, and sigma is your standard deviation. We looked at tables and how to read a table, how we start on that left-hand column, and then we go across, and on the left-hand column we find our row. We then use the next digit to find our column that we work down, and we see where that meets. That gives us a value, and then maybe another digit that we need to add on. That will happen sometimes, not every time. That will give us our probability, and then it's just interpreting the probability statement that tells us what the probability of a random selected data, a piece of data falling within that range is. Okay, mind's blowing. So I'll leave you there. Hope you guys are all good, and we'll chat another time. Ta-da.